Hello, students. Ready for a brain break? Let's go. Today I suggest we mess with the Fibonacci sequence. The Fibonacci sequence is such a sequence in which each subsequent element of the series is obtained by adding the two previous ones. If we start with 1 and 2, then the third element will be the sum of 1 and 2. That is 3. The next element will be the sum of 2 and 3. That is 5. Then the sum of 3 and 5, that is 8. And so on, ad infinitum. So, we will take this algorithm, calculate the entire range of values from 1 to 4 million, and calculate the sum of all the even elements from this range. Fun, right? Let's start by creating a new logical branch, named even Fibonacci. We'll attach it to any object. Now let's decide on the variables. The algorithm will involve a while true loop, so we need a variable to break the loop. Let's call it process and assign it the value true. We also need two variables to store the last two elements of the sequence. These will be integer type variables named num1 and num2. We will assign them the initial values of the sequence, 1 and 2. The next variable we will call num3. We will use it to calculate and store the next element of the sequence. For now, we will assign it a value of 0. And the last variable, named sum even. In it, we will form the sum of all the even elements of the sequence. Let's assign it a value of 2. This is our first even element, which is already entered into the num2 variable. We will not check it for evenness. We will immediately add it to our sum. Now we can create a loop. But I suggest not to rush. If we start our program immediately with a while true loop, we will complicate our lives. Because any errors in the code will hang our viewport. We better simulate the loop in a safer version. And when everything is guaranteed to work, we will add a full loop to the program. So, we need a spacebar. Pressing the spacebar will kind of start one iteration of the virtual loop. In this iteration, we need to calculate the next value of the sequence, check it for evenness, and if evenness is confirmed, we must add this value to the variable, sum even. Then we need to shift the values of the numeric variables. We no longer need the value of the first variable, we will replace it with the value of the variable num2, and in the variable num2, we will write the value from the variable num3. The sequence will move one element. Now you can repeat everything. Again calculate the next element, again check it for evenness, and so on. Let's try to implement the first step. Let's calculate the next element. And it's not difficult because all you need to do is simply add the two previous ones. That is, we take two variables, num1 and num2. Add their values together. And record the result in the variable num3. Excellent. Immediately put this block of code in a frame and sign it. Now, to check the operability of this step, I suggest organizing the shift of elements. For this, we need two setters. We assign the value from the variable num2 to the variable num1 and a new element from the variable num3 to the variable num2. And for clarity, let's output the calculated element to the console. We take out the print block, insert it after calculating the next element, and connect it to the getter with the num3 variable. And to make it completely beautiful, we combine the variable value with the string next num, :space. Launch the console. Press the space bar several times and see the correct Fibonacci sequence. If we take any two adjacent elements and add them up, we get the next one. We managed the first step. Let's move on. Every new element of the sequence needs to be checked for evenness. Let's think about how even numbers differ from odd ones. And they differ only in that even numbers are divisible by 2, without a remainder. And odd numbers, when divided by 2, give a remainder of 1/2. For example, dividing 5 by 2 will be 2.5. Or dividing 9 by 2 will be 4.5. In other words, when dividing by 2, the remainder of the division for even numbers will be 0. And for odd numbers, the remainder of the division by 2 will not be 0. All that remains is to understand how to calculate the remainder of the division. And there is nothing complicated about it. If we divide the number by 2 and subtract the rounded version of itself from the result, then in the case of even numbers the answer will be 0. And in the case of odd numbers, we will get a remainder. To test this theory, let's write a small script. Take another key. For example, Q. Create a variable named checkNum. And we will write a randomly generated number from 1 to 10 in it. Immediately after that, we divide the number by 2. Round the result to the nearest whole number on the larger side, using the ceil function. And we subtract the result of dividing by 2 from the obtained number. Now we take out the gate block and compare the obtained number with 0. Output all this to the console. Take out to print blocks. From the true channel, we will display a message that the generated number is even. For beauty, we use string concatenation. Number, space, value of the variable, space even. We copy the connection, connect to the false channel, change the string to not even. Launch the console. Press Q several times. And we get a list of numbers that the script has flawlessly sorted into 2 categories. And now, after you've understood the essence of the process, I'll make your life easier. This arithmetic link can be replaced with one block. In the math block, there is a built-in function that returns the remainder of the division. And in this form, our algorithm will work just as flawlessly. Beauty. We return to our cycle. After outputting the new element to the console, we check it for evenness. Gate block with an equal operator. We compare the remainder of the division by 2 of the variable num3 with 0. We place the check in a colored frame and sign it. What should we do if the number is even? Right. We add it to the variable sum even. But first, we need to check, have we not exceeded the limits of the conditional range? By condition, our limit is 4 million. While we are busy creating and polishing the algorithm, I suggest lowering this value to 1,000. So, we add one more condition. This time it sounds like this. If the variable num3 is less than 1,000. Now, to the true channel, we can connect a chain where we will take the value of the variable num3 and add it to the variable sum even. We place the blocks in a frame. We output the current sum to the console. If we launch the console, we will see a problem. Everything broke. The sequence is not generated. We see the repeating number 3. This happened because now our shift of numbers at the end of the cycle doesn't work. When pressing the key, we calculate the next element. It equals 3. We check this number for evenness, and naturally, it does not pass the check. And it is in this condition that the false channel is triggered, to which nothing is connected. And that's where our algorithm ends. There was no shift, and the next press of the spacebar will again add 1 and 2. This will again result in 3. Let's fix this. We should make the shift, regardless of the check for evenness, so the false channel should also trigger the shift process. We can duplicate the shift blocks and connect them to the false channel, but it's better to save space and not load it with unnecessary blocks without need. For this, we have a merge block. With the new button, we add two inputs and connect both branches to them. Now the shift will be performed in both cases, regardless of the results of the evenness check. Launch the console. Press the spacebar several times, and we see a beautiful picture. In the process of generating the sequence, we caught 4 even elements and added them together. Then we exceeded the set limit of 1,000. And the process stopped. Now let's pack this process into a loop. Immediately after pressing the spacebar, we insert the loop, while true, and connect the process variable to the condition. Since it holds the value true, this will start the loop. Now we need to think about where and under what conditions we will stop this loop. No need to think for long, our cycle should stop right here. Immediately after the new element of the sequence becomes greater than the permissible threshold. And to break the cycle, we just need to change the value of the process variable to false. And after that, output the final sum to the console. Now let's carefully look at the console. We have set the maximum threshold at 1,000. But in the console, we see that the algorithm managed to generate two numbers that exceeded the set limits. Neither of these numbers was included in the sum, so it had no effect on the result. But if we strive for perfectionism, we need to polish our algorithm. Let's figure out where these values came from. Theoretically, the number 987 should have been the last on the list, so we start from this point. The next iteration begins with the calculation of the next element. We add the two previous elements. 610 plus 987 equals 1597. And we see that this number is greater than 1,000. And at this point, the cycle should have been stopped, but the new element is sent for evenness check, and of course, it does not pass the test. The false channel triggers, and the program skips the threshold check and immediately proceeds to the shift. After this, a new iteration begins, in which we again calculate the next element, which equals 2584. And since this is an even element, it will pass the evenness check, and only after this, it will be checked for threshold exceedance. Now the algorithm will finally understand that it's time to stop. Have you already guessed how to fix this? Yes. Just change the order of the checks. First, we will check the number for exceeding the threshold, and then check for evenness. Look, now our console has one less number. And you might think that the goal has been achieved, and this number, 1597, although it is more than 1,000, is just a necessity, thanks to which our cycle will be broken. Yes, that is the case, but we can save a bit more resources. It was not necessary to record this number in the variable num3. Ideally, we should have broken the cycle between calculating the new element and recording the calculated value. Let's try to get rid of this unnecessary operation. So, here is our setter for the variable num3. And here is the result of calculating the new element. We insert a gate block between them and check the new element for exceeding the threshold. Now the new element will only be recorded in the variable num3 if it is less than the set threshold. All that remains is to remove the old threshold exceedance check and connect the cycle interruption to the new check. Launch the console. Now our console looks perfect. I like everything. Now, we can confidently increase our threshold to 4 million and finally find out the sum of all the even Fibonacci sequence values in this range. And this sum equals 4,613,732. If you see exactly this number in the console, it means you were careful and precise enough, and everything worked out for you. If your algorithm failed, and the console outputs something other than what you hoped for, do not be discouraged. The best way to master programming is systematicity. Try to apply the icebreaker method. Just rest. Roll back. And then try to start again. Guaranteed, on the second try, you will advance further. And doing this will be much easier. Well, I like the console, but our algorithm is far from ideal. At the very least, we could get rid of 3 variables with numbers, replacing them with an array. Then the need for the shift of values would disappear. It would be possible to simply fill the array with the sequence, and then, in another cycle, just add up all the even numbers from the array. But the lesson has already dragged on, so we rest. Bye for now.